wasted literally 20 minutes trying to look.
Oh,
You know, I'm gonna talk to him. Ask him if next time.
Did you email those?
I did.
Yeah.
He just emailed me back telling me it was okay.
Okay, good.
Oh, wow.
Here's
Weird, I can't,
that.
I can't type in chats.
Then yeah, you crossed it because
Yeah.
13.
Yeah, it's just 3800. Is that what you got? Great.
What did? Hold on. Can I look at mine?
Did you do a similar setup? Did you get how many branches? 2 branches, 2?
Yeah, too.
Okay.
Resource server.
I assume. I don't think it matters where you start at because you're doing this work.
Or did we get the same problem?
Uh,
Oh no, you didn't. That 4, 6, 3, 4.
you're done. 14.
Well, maybe our questions were out of order.
That could be. No, okay. This one's a pain.
Would you put these zeros so you could calculate?
Yeah. Well, you have to calculate every single.
I did, bro. I didn't remember.
So I just said, yeah, I can't do it.
Ran out of time.
Yeah.
Ah,
No, just kept going and going. It's weird and we're not.
yeah, can I see that question?
Yeah, yeah. Let me see if I can. We're just gonna go to the power button. All right.
See how different. Even in D3, you can. It's 10%. So hurt.
Yeah.
And even if I get a 50,
Should be fine.
because the assignments are 60.
Yeah, if you do all the assignments, great.
Assignments, and then plus that like conversion assignment
Great.
is 10. So that's 70% right there.
Yeah.
So the tests don't even really.
Yeah. Because it's 60% is
Assignment, the program.
yeah. Well, 10% of that is that final presentation, which is great.
Is it?
I think it's so you just like not too bad.
Okay. Marathon is this Saturday.
%, assignments, 10% language. So if you just do those, fine.
Share the link if you guys could share with your friends and family. Link for the is a campaign for the Student Emergency Fund. And it's linked with the group of staff, faculty, and people related to MSU Denver that will be running with the MSU Denver shirt and supporting the student fund. A small crowd today in person. Is it because the weather? Or other midterms?
Because of algorithms.
Algorithm midterm? Everybody's like exhausted. No, that's what I mean. All right, so on here, correctly to write a Scala function called inc. Takes an int, returns that number, so there will be def inc. And then so Scala has the variable coming before the type, and equal have the definition, implementation of the function. What's the type of the function? Because remember, functions in Scala, they have types. They can be used in expressions. They can be assigned to variables. What's the type? What's the notation used to describe function's type? Okay, because this function takes an integer and returns an integer. So we have the int and then the arrow separating the return type, which is an int. Easy way to get the elements of array data that are positive. We do that in Scala. I can't see your symbol, but it's almost like it's out of focus. I did my best, but it just doesn't read. I'm sorry. So filter, right? Data filter. Filter takes, this is a method defined for arrays, collections like the data array, and you pass a function. This function is an unnamed function, and it's a function that takes using the relational operator as a function that takes one parameter, and we'll compare that value with 0. If it's greater than 0, that will be true. If not, it's false. That's exactly what you want to test if a number is positive. Remember, reduce left. Remember how reduce left works? SMGN, good job. How does that work? You have 1 minus 2, so -1, -1, -3. That's -4, -4, -4, -8, -8, -5, 13, -13. What if you're doing reduced right?
-5.
Fine. So there'll be 3. What's that? It's going to do 4 minus 5. So that's -1. And 3 minus -1, that's 4. And then 2 minus 4, -2. And then 1 minus -2, which is 3. Okay? All right. So talking about the exam, I will be sending a list of topics, but pretty much everything we discussed to today. So Scala, functional programming, those higher order functions, you should know how to use them. We're going to do a practice on those functions today, and hopefully on Tuesday we're also going to do some practice. Concepts related to the lexical analyzer, right? Syntax analyzer, scoping, right? Binding of variables in memory locations. So good sources for you to prepare for the exam are the quizzes. I will be sharing test exams, okay, for you guys to take a look and see what you expect. Quizzes, right? Quizzes are also a good source for your preparations. I decided, initially I was saying that, okay, midterm exam, you guys have to come on campus and take the exam here. But I see that we're almost, sometimes it's more people that are remote than coming in person. So I decided to be more flexible and decided to have the exam in the same format that I was doing when I was teaching remotely. So the exam will be on Canvas. So you will be allowed to take the exam remotely, but you're also welcome to come on campus. The format will be the same. You guys are gonna take the exam on Canvas, so bring your computers, okay? Yeah.
Are we taking it at 4, or do we have a window?
Big one.
Are we doing the exam at 4 o'clock, or do we have a window of time?
It's same time, the class time, so 4 to 6. And the exam will be open book, so you can use resources. Of course, you can't communicate with each other during the exam, it's obvious. But you can use Google, you can use the internet, as long as you're not communicating with someone else, okay? And if you're taking the exam remotely, you have to be logged in on Teams, and you have to maintain your camera on all the time. You're not allowed to use headphones, headsets, anything like that.
Exam is going to be multiple choice or have written question?
So you should expect having questions, all sort of questions like multiple choice. You may be required to write code on Scala. Okay. Of course, it's not going to be write a syntax analyzer, right? It's going to be something short that you were able to complete a code or use some of the functional programming functions that we've been discussing. Maybe I will share a code and ask you to identify tokens. Maybe I'll give you a grammar and I'll ask you to remove the left recursion of this grammar. So homework, assignments, quizzes, examples, activities we did in class, those are all, they should be part of your, you should use those as you prepare for the exam. Yeah, you guys are welcome to take the exam any way you want, remotely or in person. All right. Any question about the exam? So give me some time. At some point tomorrow, I'll be sharing review questions. I have a bunch of review questions to share, previous exams, and I will be compiling a Word document with all these questions. And I'll be sharing for you guys to study, help study this weekend. And then on Tuesday, we can talk about it. The day is a week from today, so it's next Thursday. First question, when is the exam, right? Most important question. If you get that question wrong, you get 0. All right. Any other questions? Good. So why don't you guys open activity, I think it's activity 12. We have 2 sets of functional programming questions to implement today, or maybe not everything today, but read about currying notation. We saw currying notation a little bit when we were talking about lambda calculus, but the syntax using Scala is slightly different. So I recommend you to open the functional programming Scala and go to this section here, currying. Why don't you guys read this section, currying, that explains how to write using currying notation. Remember, currying notation is that notation that describes functions always consuming one parameter at a time. Okay, so or one argument, right? And the function is described with one parameter, consuming one argument at a time, and the return of that function, it's another function. That second function is going to consume the second argument, right? And so on. You can have many as you want, but the idea is that you're going to be consuming one argument at a time. So why don't you read this section here and see if you are able to do the first question, which is this function that takes the function that without using current notation is a function that takes three parameters. The first two are integers. They will specify a range. And the other parameter is a function that takes an integer and returns an integer. So, for example, if you call values passing -2 to 3, the function values will create a range of values from -2 to 3, and it will return a sequence of tuples. The first element of the tuple is taken from the range, and the second is the function of that first tuple element. Okay? So I'll give you some time to work on that, and then we can talk about it.
towards the end. Let's see what your one is. Let's do it. That is what it is.
That means
No. Good question. Yeah, that's all.
So if you have a hard time with the current notation, takes some time to get used to. But you can start by writing the function without current notation. Values, say it takes 3 parameters, right? So let's say low, high. Third parameter is a function, right? So let's call, we suggest calling fun. Fun, what's the type of this function? Int to int, right? So you can write int to int. Now let's implement this function.
What is the loading?
You can easily reduce the list of values using low to high, right? Low to high give you a list of all the numbers. From low to high, including those numbers. Maybe we can do a for loop. First number I'm going to call I. Low to high. Well, we can do this in 2 ways. One way, we need to return a list, right? Collection. We could define an array buffer because we don't know. Well, I guess we know how many elements we have, right? So it's going to be high minus low plus 1. But then you have to create this object and then do a bunch of appends, right? To add the tuples, right? An easier way to do that is using yield, because if you yield is different than return, right? So yield allows you to build a bunch of values that you want to return, and all these values will be put in a collection. That's exactly what we want. Why don't we use yield? And what we need to return is a tuple with the first value, and what's the second value? Second value is what? Is fun of the first value. Right? So you just need to call fun passing I. Okay. Look at that. When you put yield, the Scala or IntelliJ here already figured out that the return type, you see this is grayed out. It's just showing that this function values return type is an index sequence of tuples of ints. Okay? So let's test that. Then we change this to curry notation. So let's use the same example you're asking us to test. How about print line values of, let's say, -2 to 3. And we need a function that goes from, so it's suggesting the multiplication function, right? Well, Scala is having a hard time identifying the second parameter. Assume that the first one was int, but the second one, and the problem is it doesn't know that these two parameters are actually just one, right? One way, a workaround is just to define the function, like this is a function that takes an int and returns an int. The function is a times a. We can just do this. The return type is whatever this returns, and it's going to be an int, right? If we can replace this, still, multiplication still says it cannot resolve symbols. So let's try this way. Values will return a list, and we can do make string just to put a comma between the elements. Okay, so we got -2, and the second element is the first element multiplied by itself. So it looks fine. how can we turn this into current notation? Let's turn values into a function that takes only one and the result of that is a function that takes it's a function, right? That takes, let's say, 2 parameters, and this is the implementation. Okay, let's see what happened here. Now we have values defined as a function that takes one int, right? And is defined, right? The implementation of this function that takes an int is the implementation. This is how you should interpret this. The implementation of function values, right, is a function that takes 2 parameters and returns whatever this returns. Right? And now that we have values as a function that takes 1 parameter, we should follow like this, right? It takes 1 parameter. The implementation is a function, this whole function now, that takes 2 parameters. First parameter is an int. The second one is a function that takes an int and returns an int. Okay, so we did one step of currying, right? Instead of having 3 parameters, now we have one that returns a function that takes 2 and returns the list. We did one step. So do the other step. Turn this function here now that takes 2 parameters into a function that takes 1 parameter and returns another function. So you keep doing that. Eventually you get curry notation. Instead of saying function that takes 2 parameters, we want a function that takes 1 parameter and its type is a, so the values now is a function that takes 1 parameter. Its implementation is a function that takes another parameter, the second one, and its type is a function, that's the third parameter, that takes 1 parameter, it returns an int, and the type of this function is, return type of this function here, the whole values, right, is this. So now, instead of having 1 parameter and then 2, we can just put each individual parameter now. you can see clearly what's the type of values. Look, that IntelliJ specify the type of values as a function that takes an int and returns a function, right? This is the return type of values. It's a function that takes int and returns values, takes an int, and what's the type of the values function? It's a function that takes an int and returns whatever this function is returning, right? Which is the third parameter. Third parameter is a function that takes an int and returns a list of tuples. Okay? That's confusing, especially when to use the equal. Equal is for definition, when you're defining the function. The arrow is when you're specifying the return type of a function. Okay? The columns are used to specify the type of a function, which you don't have to explicitly set. That's why it's grayed out here, because this is was added by IntelliJ as a helper. So just understand that values is a function that takes an int, and this is the return type of the function values. So function values is implemented using this function here. What is this whole function here? This whole function here is a function that takes an int and returns whatever this function returns. And what does this function returns? This function returns you have the third parameter, which is a function that takes an int, returns an int. And what this function returns is a list of tuples. If you don't want to deal with all these equals and arrows, it gets confusing, you can, in Scala specifically, you can just enumerate your parameters. So this notation simplifies a lot. So you just put everything in parentheses and you just do equal here. Okay? So isn't that much easier? Okay, so to do current notation, it's much easier, in my opinion, just to put each parameter in parentheses, and then you just enumerate the parameters. You don't have to be purist and put everything with correct equals and arrows, and maybe just use this simplified notation. Okay. Just keep in mind that this is exactly the same as the other notation that we were talking about. Okay. I prefer this one. This is much simple. Okay, so any questions, any concerns? Good.
Makes a lot more sense when you just use the parentheses.
The parentheses makes much easier, right? The syntax. more into function programming will argue that doesn't look like what functional programmer fathers specified, right? Or wanted, right? But this makes makes the job of writing the function definition simplified. So let's look at the next one. The next one is easier. I'm just asking you to use reduce left to find the largest element of an array. Okay. So we saw that reduce left is a function. It's a higher order function that, when applied to a collection, use binary operations. A binary operation to reduce the collection to a number. Imagine you have a bunch of numbers, and you can only compare numbers 2 at a time. How would you, and using reduce left, you're going from left to right. How would you use reduce left to figure out what's the greatest element in the array? Right? So every time the operation you want to use, you want to get the maximum value at each time, right? Each time you get the maximum value, you pass it on, right? Eventually, you're going to reach the end of the array, and the last operation will return the maximum value of the array. So incorporate that and do reduce left. And it really doesn't matter if you're doing reduce left or reduce right, right? Try both. Okay, so imagine you have this array. You want to find out the largest element. So reduce left. So we need a function that takes 2 and returns 1. The suggestion is to use the maths max function. So math dot max is in two numbers. Okay. So the first iteration, 3 is going to be used as the seed, so it's going to be the first number. It's going to do max 3, 7. That's 7. Next iteration is going to be max 7, 1. It's 7. Next iteration, max 7, 2. It's 7. Max 7, 9. 9. 9. Max 9, 5, 9. And we can see that 9 is going to be returned. So let's just check that. We got 9. Does it matter if we use reduce left or right? Shouldn't matter, right? Let's do reduce right just to check. Okay. Now, let's imagine you want to use, well, reduce was good because reduce got the first element, right? If you were to use fold, fold left, for example, doesn't matter, fold left or right. But fold requires you to pass the initial value. And because we're trying to do max, you would initialize with the smallest possible value, right? So not really appropriate for this problem because you have to figure out how to initialize the first element, seed, right? So it's a case where you wouldn't use fold. But for example, some functions like factorial. Factorial is a good example where fold is better. But you can also use reduce. But whenever you need to come up with the initial value, and the initial value is not necessarily part of your list, you should use fold. So try to implement the factorials. The next one, it suggests you to use fold, but you can also do that with reduce. Define a function factorial. It's an int. So how would you implement factorial without a loop or an explicit loop, right? The loop will be in the fold function.
are we?
Use the shorthand.
Okay, so factorial. Any ideas? We start 1, then we're going to multiply 1 by 2, right? The result of that, we're going to multiply by 3 until you reach n, right?
Is it better to go up or down?
And do both. It starts going up. So if you do 1 to n, that will give you the list. See, range inclusive. Then you do reduce left, and you want to do multiplication. Sometimes it accepts the multiplication as a function passed to a function, but sometimes it doesn't. You have to investigate that because we tried here and it didn't work, right? You see, it didn't work. I'll investigate that and let you guys know why we can't do it here, but here it worked. So why does this work? Basically, we're going to do 1 times 2, and the result of that, 2 times 3, right? Result of that, 6 times 4, right? And until you reach n. So let's try factorial of 5. Yeah.
Why would we use reduce fold? That's always have the starting value.
Yeah, so you can use reduce or you can use fold left. Let's try with how would you change this to use fold left?
Change the 1 to a 2 and start with the number.
Change the start with 2 and the starting value should be 1, which is the neutral of multiplication.
Even if you just have the 1 thing.
Okay, so the first round will do 1 times 2. We'll get this first from the array. That also works. Okay. What if you want to do going down? And instead of 2 to n, I want to do n to 2. Then you need to specify the step, right? The step should be -1. I forgot the syntax. Let's try step. It's not. Google? Maybe I have it here. I think I mentioned that when I was talking about loops.
I think the keyword's by, not step.
Oh, by. Okay. Okay, so that should also work. All right. Okay, so we're done with first activity 12. Let's move to activity 13. We have more questions here. The first one is prime a function that takes an integer and returns true or false whether the input is a prime number or not. I'll give you some time to start working on these functions. A great way to practice function programming is to write functions. It's the only way.
No, just.
It's gonna be functional. That's a good idea. We have to make sure it's not zero. It's divisible by average. Just have a bunch of formulas. So much is if statement. If not, then so just let's keep it
All that. You to yield. Just look at. You to yield. I want to check if I. Oh. You just have to change all this. Wait.
so 2 is 1.
That's the function. It's returning a function. Where are we doing this? We're doing So then is that number? Takes you long, so show the raise of blank 0. There's the usually on checker design this one, which I check sense. And also basically what we do a little bit because
Prime, like everything's
that's why it's at the user launcher. It's pretty weird. It's take care of it. I hope it was not sure. That's well, I usually make up things.
What about this?
Security. Just put this away, which
Why not?
Okay. Here's an implementation. The definition of a prime number, the number has to be greater than 1, right? So I'm using pattern matching to check n. So this is how you do a pattern matching using comparison. So if n matches x and x is a number that is less than 2, it's not a prime number, right? So we're going to say false. All other cases, I'm going to get divisors, potential divisors, and we're going to check if I can divide n by any of these divisors. I just need one to say it's false. Right? I'm done with this loop. The number is a prime number. I return true. Okay. We can do some optimization. You don't have to go till n minus 1. You can do the square root of n. We can approximate that to an 8. And do this to optimize. So this is a more optimized version. Optimized version because we don't do until n minus 1. We're going to stop much earlier. Okay.
You need the return keyword on line 4. Otherwise, it just returns true, right? Because it continues to run.
No, this is outside the for. You're talking about this line here?
Yeah. Oh, I see. It's inside the case.
Yeah, that's part of the case. It's almost like each case is a function, right? This arrow thing. It's funny because Scala says that you don't need to explicitly type return, but in some situations, it's, for example, here, it gives me use the expression without side effects. That's why I explicitly wrote return. Can we get rid of the explicit typing here? See, I can't. So method is prime has return. Oh, whenever you have explicit return, you have to explicitly set a type. Can you get rid of return? Yeah, I don't like that this is grayed out. That's why I had the return in the explicitly type for the function here, the return type.
What if you remove the return and then put else after false? Then does it like it?
No, but
Then you do that weird.
you can't do an else return true because you need to wait for the loop to end.
Ah,
You can only return true if none of these divisors divide and. Okay, so it's not do else here.
is there a way to break a for each? Like, or break if some condition is true inside of for each? Or do you have to go through the whole thing?
Oh, here? Oh, then you need a flag variable, so you know, right? We end up writing more. Any other suggestions to simplify the code? I'm open for suggestions. Did any of you do differently? Sure.
Mine isn't as good because it goes through all of them. But I just did it for each. And I did have a Boolean value. I set it to false first. And then I do 2 to n for each. B equals, and then I just keep reassigning it based off of whether I'm.
So you did 2 to n minus 1 and then dot for each?
Yes. But then it doesn't stop when it hits.
Yeah,
Something.
because for each, you're going to be using to apply a function to each of the elements. What is the function that you are applying? The division, the module function?
Module.
Yeah, and you're going to apply that. You're going to have a return value. What are you going to do with that, right? So for each doesn't return, right? For each just applies the function.
Right. There's also the exists, we just looked it up. You can use like exists somehow, and it will break early, apparently, under some condition.
Exists.
Yeah, I'd never heard of it before. breaks when it hits a true statement.
I never use exists. Search it up. Why don't you guys start working on GCD? So GCD, there's the Euclidean algorithm. So search it up. The recursive algorithm for the greatest common divisor. Why don't you guys use it to implement the GCD?
It has to be done recursively. How come? How come? Exists.
Exists.
It works. Share this. This is awesome.
It feels like the any keyword in Python. I don't know if it works the same, but that's how it does it there.
Awesome, awesome work. You got it with exists. So look at this. Malcolm destroyed our implementation. So exist returns true if at least one of these function calls, right? Because you're going to call this function each of the elements of the list. So we try to check if this condition holds true for at least one element. And when that happens, we know that the number is not prime, right? If we are able to divide by at least one number. And that's what we're doing here, but we want to return not of that, right? So is there a not exist? Well, it's basically I put the not operator here, the negation. I don't know if there is a not exist. Now, that would be dumb, right? But it works perfectly. Right? Because if we are able to divide the number and by one of the divisors, exist will return true, right? not true is false because the number is not prime. If does not exist a number that is divisor that evenly divides the number, then exists is false, because it doesn't exist, that number from the list, right? We're going to return not false, which is true. That's going to be my solution, and I'm going to do here. Windows. Because this looks much more like functional programming than doing the traditional way. And to be honest, it's even I'm teaching functional programming, but sometimes it's hard for me to visualize a better way to do in come up with a solution that uses the functional programming features that we discuss in class, because it's that thing, many years not doing this way of reasoning, right? It's hard to break that cycle. It would have been different if we had started learning how to program using functional programming, right? We will have this set of reasoning set in our minds, but we are educated differently. At least I'm a little bit older than you guys, much older, and I've been educated to use loops, right, and imperative programming, sequential, right? So all these things are, it seems really natural for us. But that's the goal of this this course, is to kind of look the other way and see if we can start reasoning differently, right? Yeah, I think it's pretty slick too. I agree. And that's the goal. I want you guys to don't do the traditional way, because that's not functional programming. Using exists, like Malcolm suggested, that's functional programming. So you need to try to find those ways to use those cool functions that we're discussing. And I'm going to add exists in my list. Okay, cool. So let's move on to GCD. Here we cannot even do the optimization too, right? Just going to erase the other. Or this is the solution. So according to the Euclidean algorithm, you just need to divide A by B. If you have an even division, you can just return B. Otherwise, you're going to recursively call GCD, passing B in the remain of A divided by B. You can find the algorithm online, but that's basically the algorithm. So we just need to check B. If B divides A, if that's the case, we return B. Else, we recursively call GCD of B and A remainder division of A by B. I guess we need to tell Scala that GCD returns a function that takes an int and returns an int. Right? Here we need to use current notation. And I'm using current notation here. Okay, so GCD is a function that takes one parameter, returns, this is the return type, a function that takes one parameter and returns one int and returns an int. This function is implemented here. This is the int, this parameter here, and this is the implementation. And we can look here. So 1071 and 462. Let's try that. Oh, using current notation. 462. So we got 21, and that's the answer here. This is what we did, right? GCD. This is just going one step further. You can also do that, because if you don't return right away here, next time the division is going to be even, right? And you're just going to return the divisor, right? So which is A. It really doesn't matter. But the recursive call is B A mod B, which is B A divided by B. That's GCD. Is there a better way to do that? Or functional programming? I think I'm happy with it because it's using recursion. I can't find another way to do that. Of course, you can do a non-recursive implementation. non-recursive implementation. This one, the next one is the coprime. Returns true or false whether the numbers are coprime or the GCD equals to 1. So that's pretty straightforward. I'm going to use that other notation. So we just need to call GCD of A and B and check if it's 1. Okay. The next one is more interesting because totient pi takes an integer, returns the number of positive integers between 1 and m that are coprime to m. It is suggesting you to use until and the filter function. So the coprime is a predicate function, right? Because it returns a Boolean. So you can use coprime with filter to do the totient pi. Totient. You don't even need the braces. So how can we generate this list from 1 to less than n? The suggestion is to use the until function. So using until, you can do 1 until m, right? And then you do what? Remoters. What should we do now? when they ask me to change the filter downstairs, I'm going to say filter is actually a higher level function. My wife will look at me and say, what? Why don't we use filter? So now what? So filter applies to the list. The list is giving as callee object to filter what we need to pass to filter. The predicate function, right? The filter will filter that list and return a new list with only the elements that are co-prime to m, right? How can we check if a number is co-prime? We use the co-prime function, which is a predicate function. It's doing exactly what we want. So why don't you do co-prime? You need to pass two values. What are the values? M and underscore. That's the element we're taking from the list, right? Let's change the order here. Like
uses current, right?
it's current. I always forget the current notation. Let's try now. Okay, it worked. It's the current. Okay. So let's try tangent pi. Three, two, five. Okay, so all of these numbers are co-prime with 3, 2, 5. Just by scanning those numbers really fast, I can definitely say that's true. That's correct.
Every number is 5.
Just by looking at these numbers, we can see that none of them ends in 5, right? Definitely, this is definitely correct. Okay, so we continue next time. Continue working on this list. This weekend, I'm not gonna assign a homework. You should focus on getting ready for the exam, okay? You guys have a great weekend. Hopefully I'll be able to continue walking on Tuesday after the marathon. We'll see, maybe I'll be with a wheelchair.
Thank you. I also feel like I learned a little bit in scholarship.